Okay, good evening. Can you guys hear me well?
Yeah.
Okay, can you see my screen on the slide?
Yes.
Okay, wonderful, wonderful. Okay, let's get started. Well, first, I want to say congratulations. You guys finished the programming basics. Essentially, we are standing on the AP Computer Science A, and we are going beyond. Okay, so starting from today, we want to focus on the algorithms. We have finished the blocks in the MIT App Inventor that we intended to do. We finished them, we complete them. Now we will go beyond that. Okay, so in order to to explain what kind of algorithms we're going to cover, we actually use the USACO as our exercise, right? We follow the USACO. We follow the algorithms that USACO tests. And we use the USACO problems. We solve those problems as exercises and as examples, right? So before we start, let me introduce, let me say something, okay? A couple of things that I think is important for how to study programming, right? This is actually a slide that I used in the first class, okay? So the key to programming, how to study well in programming language. So if you're looking for one key to learning a programming language well, the key that is missing for many, well, there are a lot of things you can do, right? You can select a good course. You can select a good instructors and books and videos and other resources that you might be able to access. However, the real key is immersion. That is, you have to actually writing. You're going to write the code. You're going to debug the code. You're going to modify a lot of codes before you are really good. Okay, so this is the only way. Okay, you have to bring your brain and hands at the same time. That is the way you can learn well. Okay. Yeah, so what are others? What are others? If you really look at exceptionally good programmers, what do you think? What other characteristics they possess, they have? Number one, they focus on challenging problems. So different problems, you probably have one homework assignment or two homework assignments each class. However, your instructor, your teacher will tell you which one is a problem that you will have some challenges and you're going to benefit from them. Okay, so always focus on the challenging problems. Only when you overcome some difficulties, the next time it will be easy for you. And going forward, every time this will not be a block for you. Otherwise, the block, even though you walk around, right? You around the difficulty, but next time it's going to appear again for your whole life. Only when you solve this problem, it won't be a block anymore. Okay, that's number one. Number two, active learning. What is the active learning? The same thing as I just mentioned. You bring your brain, okay, brain, and your hands together. Okay, you cannot passively just sit there and listening and thinking. No, that's not the way to do. You're going to be actively working on the problems, the problems you're solving. Okay, so another thing is you're going to look for outstanding peer groups. What does that mean? You're going to make friends. If you work alone, there is no way you can be really, really outstanding. The only way you can be outstanding is you make a group of friends. Everyone has something you have to learn from them. Okay, that is really, really important if you want to do well. Okay, so the fourth is communication skills. Try to communicate with people. Okay, communicate with people, offer help to others. That is the way that you can, stay with a community that people can help each other. See what I'm saying? If you help people, gradually, eventually, that community, well, some people are going to help you. Okay, you're going to build your community. That way, you have access to more intelligence, more resources, and you can get help. Okay, these are so important. This is a new slide. I just found it today. I want to share with you. This is very important as well. This is very important. Okay, so studying well is not just about studying. It's way beyond just learning. Okay. All right. So the next one, I want to say, hey, how to take it, how to take this this class. I want to say a couple of words, right? Number one, you're going to be present on time. I'm not sure. I think we miss a lot of students. Do we? Oh, we don't. We have a lot of students here already. Okay. Thank you so much for attending our class. Just be present on time in class. Number two, follow the teachers and repeat. You can do the in-class lab on your own PC and your smartphone. That's what I mentioned. I said it. This is the second time I said it, right? So you're gonna do it. You're gonna actually do it. Okay. Make your hands dirty, wet. Okay. And after class, you should review the PPT slides. There is a lot of information. You probably the slides can give you a better, a more concise description than the instructor's address. You see what I'm saying? So yeah, review the PPT slides. You're gonna feel like it's beneficial. All right. If needed, you don't have to watch the video again because it takes another an hour, maybe 2 hours. So don't do that. You not necessarily do that unless you believe there is something you need to, play back, and you play that part of video. Okay. So there is one more thing is we have every Monday and Wednesday, we have 1 hour office hour session. Come and join the office hour session. We have a lot of good discussions. Okay. If you are busy, you are not available for all the office hour, at least you should join us. You should join the office hour before you submit all homework assignments. If you are ready, you really think you're good. Okay, it's not required, but I urge you to join the office hour sessions. All right, so we have now. I want to invite you to a Discord group. Okay, I have a link here. Let me see. Yeah, I have a link here. Let me paste it in the chat. Okay, so when you click the link, you're invited to the Discord group. In the Discord group, we're gonna post all information in the Discord group, number one. Number two, we're gonna provide all information in the, we're gonna make all announcements. We're gonna, put all information, and we put all questions in the Discord group. I believe you are very familiar. This is not your first course, right? So we have a Discord group. We can discuss inside, okay? I wanna say one thing. Whenever you have a question, post it now. Post it immediately. Guess what? There was a student yesterday. He showed me a Discord message, and I was not there. And he joined the office hour session, and he kept waiting while I was talking with others. And eventually, I got a question from him. He said, "Hey, which one is the homework? I'm not sure which one is. It is not very, very clear. Just a problem." what I want to say is, whenever you have a question, raise it. There is no good question or bad question. All questions are good, are valuable. And the quicker you can post it, the quicker you can get it resolved. Okay, so this is a very important communications mindset. I'm not saying it's a skill. There's nothing about skills, right? You just post it. This is a mindset. You should post it now. Okay, ask your question. Okay, so wonderful. You guys know, right? We have a master document. In the master document, that's the only link you have to keep. So in the master document is actually a link to a Google document. The Google document has all information, like for each class, like a class video, PPT, homework assignment, solutions, and even the Zoom link, whatever, the all information. That's the master document is the only document that you want to keep. Okay. Me? Well, okay. So yeah, Dr. Finn just posted the master document, I think. So yeah, we will, Dr. Finn and I and myself will keep updating the master document, but you just keep one link, one single link. You have everything, all the updated information. All right. So what else? Oh, I probably want to give you, I will share this slides with you, okay? So essentially, our class will be every Friday, 5 to 7 p.m. Pacific time. The dates is given over here, so you can check out the dates. So all these are Fridays. However, plus the very last one is the Friday and the next Saturday. That will be the last class. The last class will not be December 24th, right? December 24th is the Christmas Eve. We don't have a class on the Christmas Eve. What we want to do is we have two classes on the same weekend. Okay, the very last class is the Saturday right after the last Friday. Okay. So I will share this information with you. You should have it. Okay, what else? Yeah, office hour. So come to the office hour every Monday and Wednesday. We have an office hour. It's open. I will be here. Either I will be here or Dr. Finn will be here. So we're here to help you, to share. To help you for your homework assignments and share some insights, some knowledge with you. Maybe, a lot of times we talk about the best practice, right? The way that we can make our coding better. Okay, so I think that's all the information I want to share. I'm really glad you guys are here. We will start our algorithm journey, and I'm sure you will learn a lot in this course. All right. So now I want to hand it over to Dr. Finn. Let me briefly introduce her. Dr. Finn is a PhD in computer science. He's currently he's currently a faculty member at University of Texas in Dallas. Dr. Finn is an expert of education with rich teaching experience and profound research accomplishments. Her teaching and research interests include computer vision, multimedia retrieval, data mining, pattern recognition, machine learning, and computer games. Oh, wow, that's so cool. So now I will hand over the time to Dr. Finn. Dr. Finn, I will stop sharing and you can share your slides.
Okay.
Just 1 second.
Okay.
Yep.
Okay. Okay, I believe this is my screen. Let me just make sure I do drag and drop all of the tools.
Dr. Feng, let me make you the host.
Okay. Okay. And again, thank you, Dr. Meng, for a great introduction. I think I see a lot of returning students. I actually recognize a lot of you from summer, and I'm very happy that you guys are back. And we highly encourage you, and the reason we welcome you to come back to our class, and again as fall, is, as you all know, this session, this season is exactly the season for the competition starting in the academic, in the 2021 to 2022 academic year. Our first round of competition is right around the corner, which will be in December, mid-December to late December. So I'm very happy to see a lot of you back, and I'm definitely looking forward to you guys getting your bronze level certificate this year within this coming competition season. And then for most of you probably already know the website for USACO, and then you already know what's USACO short for. But just in case for our new students who recently joined starting this fall, we actually had a taste of one USACO question at the end of our one-on-one class, and you actually tried that. But today, as a first class, we're not introducing any specific algorithm. We're not introducing any specific strategy. We'll actually say there is most of the time, the very first question within each competition season is actually a very straightforward question. There is no actual strategy needed. You directly go ahead and try to solve it in a sequence. Just follow the flow. And then we'll see examples like that in just a little bit. And we will introduce an algorithm that Dr. Meng introduced during the office hour. And then we'll particularly talk about in details. So in order to check or review all of the questions in the past computation, we just go to the contest tab on the website, and we can see all of the questions within the past computation seasons. You can also see each season we have exactly 4 rounds starting from December through April. And on top of that, each round for each particular level. So let's just go to the last season, the last academic year. We started from December, and then we already know there are exactly 4 levels: bronze, silver, gold, and platinum, and then we're focusing on bronze. Let's first get into the door for this competition. And then as you can see, we have a total of 6,000, roughly 6,000 submissions from validated students. And then here you can actually see we have pretty much every 1 out of 2 goes to the silver level. And if you get a high score, you automatically promote to silver. And our goal for this year is we are hoping by the preparation of our class, we can make everybody, we are looking forward to see everybody move up or get the bronze certificate. Oh, thanks for Dr. Meng. Thanks, Dr. Meng, for copy paste the website. I didn't even realize we have chat. I'll just keep this box floating here so I don't miss it. And as you can see, within each round of the competition, there are exactly 3 questions. And these 3 questions are exactly arranged from the simplest to the hardest. So the difficult level goes up. So you always know that the first question is guaranteed to be the easiest. And then for every question in the past season, you will see the name of the question. The particular question we're looking at today is, do you know your ABCs? And then for this particular question, there is, of course, the first link we can click on is look at the question. And then before we, after we look at the question, we'll also go to the other two links right here. We're trying to explain a little bit about what is the test data and why we want to do the test data. And for all of the questions in the past season, they will give you a solution, or they will give you or provide some ideas or some sample code from the summations they got, just to give you an idea. And let's say, for example, if we are going into this year's USACO 2021 December contest, when that is ongoing, we won't be able to see solution right there because it's ongoing. So let's first see this problem. I particularly picked this question. This is this is from last year, very close, not like an ancient question. So it's just a question from last year. And on top of that, this is in the very first round and the very first question. So this is really, I would say, among all of the questions I have seen, this is the simplest USACO question I have ever seen throughout all of these years. And to be honest, I particularly picked this question is I believe that as long as we read the question, you do a little bit thinking and analysis of the question, that you definitely can do it. So let's make sure everybody has a confidence. We can definitely get this done. We know exactly how to do this. So let's see the question right here. Let's see if I can enlarge it a little bit. Okay, right here. Let's see if I can make it even larger. Here we go. Okay, so it's easy to read. So another thing about all the USACO question, I think I have mentioned in our previous class that they really like this farmer and then cow scene. So they always have a story about it. So the first or the foremost or the most important part for solving the question is reading comprehension. So read the question through and filter the useful information and versus, let's say, not really useful. Specifically, what I like, I usually refer this as filler information, or let's say like something to transition the story from whatever they're telling for the farmers or the ranch and the cow to the actual question. So the most important and the very first step is trying to filter out the useful information. So let's read the story first. Farmer John's cow have been holding a daily online gathering on the Moose. Actually, it's just the reverse of Zoom, if you know this. Moose video meeting platform. For fun, they have invented a simple number game to play during the meeting to keep them entertained. And Elsie, that's one of the cow, has three positive integers, A, B, and C, where A is less than B, less or equal to B, and that which is also less or equal to C. So they're in this particular order, in ascending order. These integers are supposed to be secret, so she will not directly reveal them to her sister Betsy. Instead, she gives Betsy 7 not necessarily distinct, so there could be duplicates, integers in the range from 1 to a billion. So that's how large the number could go. Claiming that, again, 7 number, they're correspondingly A, B, C themselves, and the sum of any two, which is A plus B, B plus C, and C plus A, and the sum of all three of them in some order. And then let's see if we are LC and if we are BELC, and then another count give us exactly 7 numbers, we want to specifically say, can we find out what number is A, what number is B, and then what number is C? So that's why the name of the question right here is called, do you know your ABCs? And then before we even continue, this is a very interesting question, which is just a simple math question. If you think about, we have 7 numbers in any order, which is exactly A, B, C, A plus B, B plus C, and A plus C, and A plus B plus C. So before we even do anything, let's just think about the 3 number. Here's the very useful information. All 3 number are positive integer, and that specifically comes within the order A less than B less than C. So if we have 3, or let's say even if we do not know any of these 3, and we have 7, we can always use algebra to solve the question. Now, the thing is, how can we write a program to find ABC? Yes, very good. ABC cannot be negative. They are positive integer. Very good. That's very useful information. So let's just think about it. Let's just make one example. What if my 3 number, let's just say A, B, C is exactly 1, 2, 3. And if they're exactly 1, 2, 3, and let's see, what's A plus B? 3. What's B plus C? 5. What's A plus C? That's 4. What's A plus B plus C? That's 6. And then if we're not sure, very good. We have a very good observation right here. The biggest number is guaranteed to be the sum of all 3. And if you can observe that, what happened here? Oh, I'm sorry. I need to switch in here. What's about the smallest? Okay, very good. So we already have Leo. Leo already find out that the biggest number is the sum of all 3 ABC. What about the smallest? Very good. So here the smallest is guaranteed to be A. The reason is A, B, C are 3 number where A is the smallest. Actually, now think about A is the smallest for sure. A plus B. Oops, sorry, my mouse is not working very well. A plus B plus C is the largest. And then where is B? Where is C? Where is B plus C, A plus C, and all of those? And you can even think about this particular example I came up with, and then trying to see. So Aaron had a interesting comment, but A plus B is not the smallest. So let me just ask this question. Who or which number is the second smallest? Anyone? Very good. B. So now at this moment, you see this question is already solving itself. We know, let's see, the smallest one is guaranteed to be A, the second smallest is B, and the largest is AB. A plus B plus C. So if we just know these three numbers, I can find out C equals the largest one. Let me type. My mouse is really not working today. C equals the largest minus the smallest minus the second smallest. So as you can see, this question is before we don't just go ahead to write the code. The first step is always trying to analyze and then try to read and then do some examples. And then from the example, find out the pattern. Then you can try to work out the code. So now we have done some of these thinking, and we find out smallest is A, second smallest is B, and the largest is A plus B plus C, and then that's how we find out C. The question just asked for A, B, C, and we already get our answer. Now next step, let's verify every question within USACO. You probably remember that also comes with sample input and a sample output. So let's see the sample input right here. For this sample input, we have 2, 2, 4, 9, 7, 9, and 11. So if we try to put them within the order, so let's see, smallest is 2, second smallest is 2, and next one is 4, and 7, and 9, and 9, and 11. So these are the 7 number we have. So we already know A is 2, B is 2, C is 11, the largest, minus A minus B, which is 7. So we know C is 7. So the solution right here is 2, 2, and 3. That's exactly what we wanted to work with. And then now, again, before we go next, there's another thing we would like to do. So before you actually switch to writing the code, is verify your logic. Our logic is finding the smallest, finding the second smallest, and then finding the largest. And then we know ABC. Now to verify our solution is correct, and this is where they provide us, if you notice right here, test data. So if you do click on it, and you will see there is a zip or compressed file that will automatically be downloaded. And if you click on it, and you will see what's inside. If you notice, it has 1 in, 1 dot out, 2 dot in, 2 dot out, and most of the question, let's say 90% of the question from USACO has exactly 10 set of test data. What we refer as test data, as you can see here, A is exactly the 1 dot in. So in is short for input, out is short for output. So it gives, let's say, if you give this 7 input number, which exactly is the sample input and sample output we see within the question, then the correct answer should be 2, 2, and 7. Let's verify our logic using another set of input value. Let's see what we have here. In this particular example, we see the numbers here are 41, 19, 22, 38, 22, 19. So let me try to rearrange them as 3, 19, 19, 22, 38, 41. Did I miss a number? Oh, there's 222. Okay, so this is how we have. Let's use the same logic. First one is 3, second one is 19, and then the largest one is 41. So 41 minus 3 minus 19, and that's exactly what we have as 19. So the string number should be 3, 19, 19. To verify you can go click on 2.out, and then you can see the exact string number are 31919, just as we discussed. So for this question, it is so simple and straightforward. We probably don't really need to continue to verify, but it definitely makes sense sometimes when you come up with a particular pattern and a method to solve a question, you wanted to verify and cross-check what's the solution. Another reason you wanted to cross-check with the solution is that's exactly how USACO evaluate your submission. If you notice, everybody who's participate and you will submit your, so if you still remember, go to the main website. This is exactly how and where you participate within the computation. You wanted to first say register for a new account. So let me just do a dummy account, just a demo. So I'm going to put 9999. If you notice right here, that's how the school, or that's how the system know that I'm not a valid, or I'm actually not a participant going for the actual result. I'm just doing this for fun. So as soon as you have that, and then you actually register for a new account. And if you still remember, we did that through email. Then you need to check your email box. Within your email, that's exactly where they give you the link, so you can finish the registration. And then after you have done that, then the next thing to do is you can log in. As soon as you log in, you will see a slightly different portal where that portal is. Actually, let me see if I can show you that. Let's go to my UTD email account. Here we go. We already see it right here. USACO, and then this is exactly where we have your new account has been created. Log on at USACO is the next 24-hour with, here is my original password. Let me copy paste. Log in. Okay, so now we have logged in. If you want, you can always modify, let's say reset the password. As of now, I don't want it to reset. I just want it to directly go. Go ahead, and then let's try to go through questions. And let's try to go to problems here again. And as you can see, you will see a slight different portal right below the question right here. If you notice, right below the question, and on the very bottom, this is where you can never. You're gonna see particularly choose your language, whether you're working with C, C++, or Java or Python. These are the supported language for the summation of USACO. I know a lot of you have questions that we are using MIT App Inventor. For this particular question, the test case is actually not that complicated. The reason is because there are only 7 inputs and there are only 7 numbers. The only complexity is the number grows to much bigger. So if you see the number is much larger, but still the calculation is exactly the same. So for this easy question, this question is very easy, so it's not very complicated. But if you still remember the alphabet question we did at the very end of USACO 101 class, let me see if I still have that. I might. So here's an example for the alphabet. So quick example where we still have the alphabet, but what Farmer John remembered is a whole song, which is many, many characters, much more complicated than the sample or the example we get, which is mood. So that's another reason, and particularly how we get graded, like how do we get our score from USACO, which is by the test case. On this platform, for example, I personally like to use C++. I'll choose C++ 17, and then you submit. For example, I have read the code. You submit your code, and then after that, you click on submission. What happens is as soon as you submit, since it's a C++ source code, that source code will be run exactly on the platform, on this website, on the server. And as they run it, how do they run? They will try to run your code against the exact 10 test cases. It will try to check for all different 10 input, this 10 side of input numbers. First thing they wanted to check is your answer correct, which means is your answer matching with what they have as the out, which is the standard correct solution they provide. So the first step they check is whether you get it right. So if we go all the way up to see analysis right here, it gives exactly, let's see, how many summations from all different countries right here, different place. And on top of that, how many summations are being graded. And then here's another thing you see here. C, actually C and Java, the most popular summation here. And then after that, you can also see what they are checking after that is how fast or how good is your solution. They will check a little bit more details on your code. And that's how you get the rating, or that's how you get a score. And then that's why we're having here is for all three of the question, you get some score. And if you get a certain score, you will be either getting your certificate for bronze level, or you may even be qualified and promoted to the silver level. So that's in general what happens. Now let's go back to a little bit let's go back to the actual question. So on the master document, you can actually see we provide a PowerPoint. In the beginning of the PowerPoint, it did give a little bit more overview and introduction about USACO. And I did mention that even though we are not using C++ and Java right now, even though we're not doing it right now, this MIT AI2 is actually the most popular environment for beginners to start, because the logic, if you notice, the whole thing we did so far is about the logic. As soon as we figure out the logic, we can write code in any kind of language. And then same thing, you can check out the slide in the beginning, it has all the same thing. And here's the key, which is finding the smallest, finding the largest, and also finding the second smallest. And for that, we need that's what we need, sorting. And then sorting is such an important algorithm or important operation that according to statistics, more than 70% of all daily computer operations we are doing. Let's say everything we're doing, like even all the apps we're using, everything we're working on our computer, 70% of them are sorting. And there's another thing called the searching. So these two very basic operations, we wanted to particularly talk about it, and then just briefly introduce the idea. and then see how we can use this. Dr. Meng has already introduced a little bit and provide a tool called a tool within MIT AI tool we can directly use. But let's still go over the concept of sorting, and then we're going over the simplest, the most straightforward simple sorting algorithm for our class, which is bubble sort. So what exactly is sorting is you get some random other number. That's exactly what happens within the question. You get 7 numbers in any random order, and we wanted to rearrange them in ascending order or descending order, a specific order we assign. That's what we refer as sorting. And it's not necessarily just a number or alphabet. So if you think about our dictionary is arranged in alphabetical order, so our dictionary is actually a sorted list of words. So it doesn't necessarily to be a sorted number. It can be sorted alphabet. It can be sorted words, sorted sentences, sorted articles, or anything like that. And then the reason or where we get the name for bubble sort is the concept is we bubble up the largest element, and then let's see exactly how this is done. So if you still remember when we talk about list in our 101 class, we did talk about we can loop for from every element, each element at a particular index within the whole list. So we can go through every single element or atom within the list. And then we go from the beginning to the very end. And then every time, so the particular term we refer as bubble, but you can think about it just we are doing what we refer as pairwise comparison. So let's see exactly how this is done. And then after we get this done, we have the largest value being bubbled up to the very last position. So let's use this example. 6 numbers, 77, 42, 35, 12, 101, and 5. Let's see exactly how this process works. In the beginning, let's start from the beginning, from the very first atom. So let's compare, and that's why we said we need a pairwise comparison. So we need to compare the first one with the second one. And then we know 42 and 77, and they are relatively sorted. So forget about the other 4 number. Just imagine we only have these 2 number ones in the list, then they are already sorted. So don't do anything. They are relatively in the right order. Don't mess with it. Let's move on to the next pair. And then the next pair is 35 and 77. Whoops, I'm sorry, 77 and 35. That's the next pair, if you notice. And then when we move to the next pair, let's see here, 77 and 35 right here, they are in the reverse order because 35 is less than 77. So 77 should be on the right, and then 35 should be on the left. And that's why when we move on to the next pair of number, which is 77 and 35, we need to do a swap them. And next, if you notice, we have 77 and 12. That's the next pair. Again, 77 is a larger number, so 77 should be on the right. So let's swap it again. And the next pair, okay, so this time is good. We have 77 and 101, and they are relatively in the right order. Good, we don't need to do anything. In the next pair, we do not need to, they are already in the relatively right order. And finally, the last pair we need to compare, or the last pair we need to check is 101 and 5. 101 is larger than 5. So this time we need to swap them again. So let's swap. And at the end of the swap, let's see what happened. The largest element got bubbled up to the correct position. This is the largest number, and then it is at the very end of this list. And if you see this, exactly what happens. Now, what's next? When we did this entire process, starting from the first pair to the last pair, when we do the comparison, what we managed or what we accomplished is, let's see, from the beginning to the second or to the last pair, we did pairwise comparison, and we achieved to have the largest item being sorted or being placed at the right position. That's exactly what happened, which means if you think about, one number is sorted. And then what's our ultimate goal for sorting is all numbers to be sorted. So if that's the case, we just repeat this. So our next step is to repeat. Now ignore 101 now. Just ignore 101 now. Let's see now, imagine now we have, this one is sorted. We have 5 numbers that we need to sort. Just one sec. Here is the master document. Let's come back, sorry. So this is exactly what happens for, and let's say we still have 5 numbers that we need to sort, and the last one is sorted, so we can forget about it now. And now we just repeat exactly what we did earlier. So 42 and 35, let's compare it, and we need to swap. So we move 42 here. So let me do the process. These two, we need to do a swap. So we have 35 and then 42 comes here. And then after that, we check the next pair, 42 and then 12. So we need to swap again. So we have 12 and then 42. And then after that, 42 and 77, we don't need to swap. They're already in the relative right order. And then the next pair, 77 and 5, we need to swap. So we have 5 and then 77. And if you think about it, makes sense. 77 now is it's the second largest. And then it's being put in the right position. We have sorted. And then now we have, what's the next is we have 4 numbers left that is not sorted, 35, 12, 42, 5. Repeat exact the same process, and then we'll have all of the number being sorted. The next largest number, which is 42 being sorted. And if we continue this, we definitely have all the number being sorted. So let's have a look. Repeat this process. And now how many times we need to repeat this? Think about, imagine we have a total of n items within the list. Well, let's see this first. In this case, we have 6 numbers. First time we did it, we get the largest number done. Second time we do it, we get the second largest, third largest, fourth largest number, and the 5th largest number. And if you think about it, at this time, we do not need to do the 6 or the last, because if the other 5 numbers are sorted, and then the first one or the number being left right here will guaranteed to be the smallest. So this tells us if we have n numbers in total within our list, we need to repeat this process for exactly n minus 1 times. And then we would definitely get our entire list being sorted. So this is exactly what happened for bubble sort. And this is also exactly what Dr. Meng helped us within our, just one sec. here we go. I'll try to share this link on our master document too. I forget to copy paste this, but this is a perfect demo for, here we go. How do we do bubble sort? So let's just look at exactly what we have here for this procedure sorting. For each number, from the first one to the last one with the list, what we wanted to do, and again, is actually second, because we're comparing the first with the second, second with the third. So the first number always start from the first and the second from the second. So what we're doing, if you notice, we're selecting exactly, say, just imagine the first, the particular index here, and the second index. So if the first number is less than the second number, then we particularly, let's see what we have. Oh yes, that's exactly what we did. Let me see if I can swap this back to here. Okay. So we particularly select the number, and if you notice, we try to replace. That's exactly what we did, which if you still remember, we need a temporary if we wanted to do swap. Every time when we work with a code, let's imagine we have two variables, A and B. In order to swap A and B, we cannot directly say, well, give the value of B to A and then give the value of A to B. We cannot do this because when we try to give the value of B to A, the previous value of A has been wiped out. And then we have lost out. It can imagine that A cannot remember. So A only has the current value, but A has forgotten what the previous value, and then A has no, so we lost the previous value, and then there's no value now giving to B. So we only did a swap halfway. So that's why every time when we wanted to do swap with a computer, you can imagine this is like, we need someone to help the variable here who is very forgettable, who cannot remember the value. That's why we create something called a temporary. So that's give the value of A to temporary. So temporary actually try to help A to remember. This is your old value, for example, 5. And now we can particularly say, let's give the value of B to A. Now A has what used to be the value of B, and then we give the temporary value, which is the memory of A, what it used to be, and then let's give it to A. And then you can see this actually kind of like a circle. And within this circle or within this flow, that's how we get swap done within code in computer. So that's exactly what happened here in this example, that as long as the two numbers are not in the right order, then we swap them. If they're in the right order, we don't need to do anything. Just leave it alone. And then what we wanted to do is we just directly out. If we continue this for every single element within the list, we were guaranteed to have all of the number being sorted. This is exactly what happened for sorting, and Dr. Meng did give an example. Let's see, if you are giving all the numbers like this, separated by comma, and then you click on the button, say sort, and everything will be put exactly right here. And this is just the sorting tool that Dr. Meng provided us. I'll make sure I give the link of this tool to everybody on our master document. So every time when you need sorting, and then you know you can directly reference this, and this is particularly in bubble sorting too, bubble sort. And then now we have this exactly sorting too. We know exactly how to do the sorting, and we wanted to solve the particular question for this. Do you know your ABCs? And then let's think about it. All we need to do, let's write our own guideline or outline. Imagine we're writing an essay. So first, sort the numbers. Well, let's see now. Let's first do rate or load the 7 numbers into our program. As soon as we load them, let's sort them. As soon as we sort them, and then let's just directly output the first item as A, output the second item as B, and then last output the, let's say output the largest, subtract smallest, or subtract A, subtract B. That's exactly what we need to do in order to solve this question. So let's take a 5 minutes break. We'll be right back. And then let's try to see if we can put this within MIT App Inventor. And then as we put it in MIT App Inventor, we will also show just a little bit that how we can do a small, because this is so easy, we can try to do a small conversion in Java. And then we can actually try to see how we can get this done both within MIT App Inventor and then also within Java. So let's take a small break. Let's take 5 minutes break today. Let's take the small one. And then so maybe we can end the class a little bit early. So let's see, instead of a 10-minute break. So we'll be right back. And I think we can be back at 8:07. That's when we will be back. Hello, welcome back. So let's continue. I see a very good question. So let's talk a little bit about the question. And this is actually my apology. I have to keep 2 tabs in order to keep both sessions on. I see a very good question, even though it's only to me, but I'm going to copy paste it here. So everybody can see it. This is a very good question. And then good observation. I didn't even realize. I thought Dr. Meng gave me a bubble sort, but apparently what Dr. Meng did, this particular sorting tool is not bubble sort. I also need to update, and I will give a separate. I'll try to make a separate bubble sort tool, so you can actually see the implementation. So if you still remember from these slides, if we are doing bubble sort, we should, and when we do the comparison, if it's less than, we are doing nothing. Only if it's greater than, we do the swap. But within the code, within the example sorting tool that Dr. Meng gave us, we are not, we're not doing less than, but not greater than, but it's less than, then we do the swap. So here is the reason. It's not the idea of bubble sort, but it's similar. Let's see. The first thing, if you notice, the loop here is from 1 to the last, 1 to the last. So that means let's think about the first iteration. Let's imagine we have 5, 2, 4, 3, 1. Let's see, these are the 5 numbers we have. What we are doing is 5, if you notice, then we get into the nested inner loop. 5 compare with 5. Of course, we do not do anything. 5 compare with 2. And then if you notice for this one, we do nothing. Then 5 compare with 4. We also do nothing. 5 compare with 3. We also do nothing. And then 5 compares 1. We also do nothing. So if you're trying to do the corresponding comparison, so the loop right here is every element compare with, starting from this element to the very next, and then 2 compares 5, 2 compares 2, 2 compares 4, 2 compare with 3, 2 compare with 1, and that's how we try to do a swap. So this is a different method, and then you can see the problem with this. We are doing redundant comparisons, and if we're trying to do this, so this is the sorting tool that's provided by Dr. Meng. But if you're trying to load this and then you check, it actually works. You are sorting the numbers within ascending order. You just need to do some analysis like what we did here. Imagine we have these 5 numbers and then we're going exactly these 5 iterations. And then that's how you can specifically find out. Let's say when we do 5 compare with 2, that's when we actually do our first swap. We do 2 and then 5, and then we do 2 and 4, and then we swap. So things are slightly different if we are working with this method. But anyway, my apologies that I did not realize that the sorting tool Dr. Meng provided is actually not bubble sort. But anyway, it's similar idea. The idea is similar. Pairwise comparison. I always compare every 2 and see what we need to do. And now let's continue with what we want to do here. Let's just do, let's see, the 7 numbers. And then I'm going to put a text box right here. Within the text box, I'm directly putting the 7 number from the question here. And I'm using the same convention again in the question. They are giving exactly separated by space. So I am also gonna separate it by space. I just directly do 2, 2, like just copy paste the numbers right here. And then let's just put a button. Let's say get ABCs. And then I'm going to put a text box where exactly is where I'm going to print or show the result. So I'm going to make it big, maybe multiple lines. I don't know. I probably wanted to write them in multiple lines or maybe within the same line. Does not matter. So I'm just changing it to a different shape. And that's pretty much I wanted to do. Or let's also put a button here called clear. So in case we wanted to enter some new numbers, and then we can test if it works. Then we need to go to the block view. Within block view, all we need to do is literally one button got clicked. We wanted to display the result, right? Set text box to .text to the result. That's exactly what we wanted to do. But how do we actually calculate? In general, it's always a good idea to separate things into different functions or procedures. You also remember that with an example, Dr. Meng also put it was into procedure. We like to do things that way. So it's always, if anything goes wrong, we know exactly where it goes wrong, and then we can quickly go over there to identify the problem. So it's always a good idea to separate the tasks. And if you still remember what I typed earlier, the first step is to process or get input. Literally generate, in this case, generate our list. And then the second process will be exactly sort the list. And then as soon as we sort the list, we will get the value of ABC, and then we can directly print out the result. So that's, if I separate things within these steps, that's exactly what I need to do. And then on top of that, before we start the code, we also need to particularly set the variables. For example, we have exactly A, and the B and the C. To begin with, we do not know their number. We hope after the calculation, we know what exactly is the number. So I'm just directly going to initialize A, B, and C out to 0. So let's just see. And then also, if you think about, we need to process our data, and then we're specifically putting our data into the number list. So let's just do number list. You can do any name you want, and I'm going to create an empty list. Create an empty list. And then when we process the data, and the data is exactly, if you notice right here, within text box 1. And then so what I wanted to do is go to blocks view. And then if you still remember, we have the exact two within text, which is split at spaces. So for the text within text box 1, I wanted to split them at these spaces, and then I'll just directly, here we go, set. Let me rearrange the other here. That's exactly what we need to do. The black right here, split and spaces, will be exactly separating or split the text at every single space right here. Let's say space here, so we separate 2 and 2, and this space right here we separate 2 and 11. The space here we separate 11 and 4. So we do all of the corresponding splits. And when we do the splits, and it will automatically put every individual word into a list. And in this case, it would automatically recognize it as number, and then we put it into our list. That's exactly how we process the data, and then we get our list. Now we get our list, we can just sort them. And I'm going to be a little bit lazy. So what I'm gonna do see if I can directly copy paste. So I do not need to. Put it again. And if not, we will try to put all of the block together. If I'm lucky, I can copy paste. Let's see. I don't think I can. Okay, I cannot copy paste, but good news is I can put it side by side. So I just exactly duplicate what we have there. From 1 to length of the list. Let's go to list, and then let's go to length of the list. Right here. And let's do get this list. That's exactly what we need. And then let's do another loop. Number. Let's do. Actually, for easy, I'll just use I and the J. It doesn't matter, just my personal preference. Actually, just for fun, why don't we do bubble sort ourselves? This means if you think about the process of bubble sort, what we have is compare first with the second, compare the second with the third was, so what we're doing is, if you think about with, and I say first, so starting from the first, and then we're trying to do starting from I plus 1. I need the math here, plus.
Wait, why are you doing length of list minus 1?
Huh?
Why are you doing length of list minus 1?
Because, here, let's go back to the slides. The last comparison is between 5 and 6. I do not have 6 compared with 7.
Oh,
Does that
okay.
make sense? So I go from 1 to 5. For I is the first number, which is 1 to 5. J is the second number, which is 2 to 6. Does that make sense?
Okay.
So that's why here, if we try to do the bubble sort, and that's why we have, let's say, if I is start from 1, and then J will be the current I plus 1, starting from there. And then we always do the comparison. And then so I stops at minus 1, and then J will stop at the last. And then what we need to do is we wanted to do the comparison. Let's do if. Oops, here we go.
Dr. Fong, will this be bubble sort then?
This is bubble sort. Yeah.
So if you compared to the one that you showed us before, the one that Dr. Mong did is not a bubble sort, but the one you're doing right now.
The other one is not a bubble sort.
The one that you're doing right now is a bubble sort.
Yes.
Thank you.
I'm sorry, I didn't check. I thought Dr. Meng gave me a bubble sort. Again, apologies, because he gave me this in the afternoon. Let me see if I can. go. Or let me see. We probably don't even need to do it this way. Let me think if we can do it in a more efficient way. Okay, I'll do it in a more efficient way. Just 1 second. Let me manipulate all of these, and then I will explain. Select get J and get list. Plus, this is more efficient. Do this. Comparison. Where is my mouse go? Here we go. Here. Greater than. Let me see if I can put it here. Okay, let's see. Is this gonna be more efficient? Then we make a swap. Zero, set, two. Okay, and then replace. See. Now one more replacement. Index. Okay, this is exactly what we need to do. Let me pull up this so we can explain. If you still remember from the slides where we did the discussion, I still need to move this one here. How many total time we need to repeat is exactly n-1. So that's why within the very outer loop, I did n-1. That means how many times we have to repeat the particular process. And then for each particular process, we are going from the first to the second last. And that's why, again, I did a -1. And then what we're trying to compare is this current, let's see the first one, and the next one. So first and the second, second and the third, third and the fourth, where when we stop at -1, we're actually compared with the last. In the example, would be 5 and 6. And that's why this time we're using greater than. If it's greater than, then we do the swap. The particular swap, again, we need a temporary. So let's get AI, or let's get the jth element to temporary. And then let's replace the j's with the j+1, so the next element. And then we replace the next element with the current one. This is exactly how we do the swap. So after we done this, now we should have this finished. I'm going to rename this as a bubble sort. So we know exactly the two different sorting algorithms, those two different sorting ways to get things done this way. So as soon as we have sorted, we are able to know exactly what's the value for A. So let's particularly do set A to first element within the list. So I'll just directly do select the atom within the list, because now the list has been sorted, and then it's exactly index of 1. And now I can do whoops, I'm sorry. I'm setting A to this. And the same thing I can set B to the very second. And then I can set C to this time, we just need to do subtraction. And the subtraction will be exactly, I need to subtract it twice. So I just do this. Let's first do the last one. Sorry, let me see if I can bring this down here. So in this case, we have exactly 7 numbers. So it exactly is the 7th, which is the last one. Subtract, let's just get the value of A, because we already know A, so I'll just directly do subtract A and then subtract B. And then now I need to do is join A, and I probably wanted to put a comma or a space, whatever you want to separate, and then we just add more. 2, 5, and let's do B, and let's do comma, and then let's do C. That's all we need to do. First in the list, the second within the list, and last one the list. But again, before we do that, I forget to add, we need to first get the data to the list, and then I need to sort the list. And as soon as we sort the list, we know first number, second number, last number, and then we do the corresponding calculation. We should find our result. So this is what we should do at this moment. Let me see now, moment of truth. might have typos in here and there, but let's try. Let me first try to see if I can connect and then run this. And then I will try to show the result. Let me first note. Okay, so let's let me try to refresh, and then let me see, where is my camera? Okay, here we go. Here we go. So this is exactly what happens. The moment I try to connect, since I already have it, I didn't input any particulars. I just directly use a sample, and then we have 2 to, whoops, I'm sorry. We have exactly 2 to 11, 4, 9, 7, 9, and that's all the numbers. And then click on the button, you see exactly number 227 being printed out, and that's exactly the right solution we have here. I don't want to spend time to do more on this, but I want you to particularly finish and then try to write, for example, when button 2 got clicked, if you remember, that's clear. What we wanted to do is we wanted to clear the previous list. We wanted to clear the previous value for ABC, clear the text box, so I can enter another 7 number, and then I can try to see if it works when I put 7 different numbers. That's where you wanted to put the 7 numbers, maybe from the text, from the test data, which is on the website. That's exactly what happens there. So the reason I want to stop here, I wanted you to specifically finish this, try to test and then try to do the clear button, is because I mentioned I wanted to spend a little bit time to specifically see how we can convert this to Java. You can use any comfortable IDEs or any Java platforms like Eclipse, NetBeans. These IDEs are very popular and well-known and famous. AI2-202, these are all very famous. I personally always use this online GDB. The reason I use this is because if you notice, I can choose any language. So whichever language I'm teaching, I can switch it. And this is a very good tool. I can directly demo online. So I'm going to do a quick demo for the exact same thing, how I am going to put it within Java. And then how we can quickly do things within like convert, or just to do a block by block session of converting things from MIT App Inventor to Java, so we can directly, and we can do a smooth transition. So even though we are working on all of the logics and programs using MIT AI2, you can easily work out an actual workable code that you can submit to USACO. So this is one of the online Java compiler I like to work with. You do not necessarily work with this, but this is one thing I really like to work with. So, whoops, I'm sorry. So this is particular what we have. So many times, you probably, when you're trying to write a piece of Java code, it's very common that you wanted to include some additional libraries, which you can think about what that was, is the built-ins. So if you think about when we're trying to work with MIT App Inventor, we have a lot of big built-ins, which we just directly drag and drop these blocks, and it does a corresponding thing for us. We don't need to do anything in addition. So you can imagine that's similar. What we refer as those blocks, let's say built-ins right here, in order to use some of the built-ins. We need to to this import stuff. So depending on which kind of built-in. So as you notice, we have different color. Let's say this is all the control built in. This is all the math built in. This is all the dictionary built in. So when we work with Java, it's very similar. So other than what I'm doing here is everything the built-in from the utility, short for utility. There's also, for example, java.io and that treats that particular handles the input output file if I wanted to read data from a particular file. So which particular built-in, you can think about different words here as like different colors, like we did within MIT App Inventor. Then as long as you start a brand new Java code, they always provide you something like a template, something like this. So you can just leave it alone. You don't need to do anything. You just directly imagine this is exactly right in the middle, and that's where you wanted to put in your own code. Yes, if you are comfortable, you can directly work it. Our class, or my personal opinion, or my goal is, do we really understand the question? Do we really understand how to solve the question, the logic, the pattern, and how do we identify those to solve the question? Which particular language we work with, and in my personal opinion, is actually not really, it does not really matter. The idea of solving the problem is actually the bone, and a different kind of language, I would say, is just like on top of the skeleton, you just put different kind of clothes. They may have a different look, but they actually have the same skeleton. They're exactly the same person. So that's my personal opinion about different programming language and then solving things in different language. So let's continue. I really wanted to wrap this up quick. So in order to work with, so again, I'm going to work things in a very simple way. So I'll just directly do input number. Let's see, we have all the 7 numbers. In order, I'm going to put the 7 numbers specifically within a array. I'll just directly do a 7 integer array, and then particular, I'm going to do the very same value right here. Whoops, exactly. Where did I put my USACO question? Here we go. Sorry. 2. So let's come over here. How do I directly copy? And now here within Java, we need to do separate by comma. So that's exactly how I put these 7 numbers into an array. That's how things are arranged within Java by default. If you want, you can also work with list. It doesn't matter, but again, I think Dr. Meng made a very good comment. You are definitely welcome to provide Java solution, or if you are comfortable, we also welcome you to submit Python solution. If you do know C++, I would be more than happy to see you submit additional solution in C++. Yes, exactly. Use MIT App Inventor as the structure, as a bone, and then use that to help us to do the translation is the best way to do things. And then here's and then in this particular part, this is one of the most beautiful part about oh, I may not be able to do this online. Let's see if this is allowed. Let's see. I believe it's allowed, or let me double check. But anyway, before we try, if not, we will do some readings. But the beautiful part about the built-in of Java is Java already provides us sort block. You can imagine that. You can directly use sort. And then the way to use it in Java is called Java array.sort. So as you can see, where is the Oracle Help Center? This might be a little bit. Let's just use this. As you can see within Java, we already have, oh, I think I know why I accidentally had a typo. And so within Java, it already provides this. We do not even need to write the whole, but the good thing for us working things in MIT App Inventor here, by doing the bubble sort ourselves is a great way to help us get clear about the logic. And that's why I was very happy to see Leo ask the question, why it's not greater than, but less than. And then so do the exact implementation for the sorting helps us, which is a great practice to get better in coding. But using Java or C++ or Python, it does provide us, we already have this amazing built-ins or block, which is called sort. We don't even need to do anything. It's already there. And as soon as we do that, that's also why I did import Java utility, because this sort block is inside of this utility. So we can directly work with that. And then now we can directly do system.print line. So this is a particular function which literally print out the result on the screen. So we can immediately see the result showing up right here in just a little bit. So I'll directly say A is number A is, and I'll put a space. And you want to give the particular value, and that particular value is exactly the first number within your input array or input list. And then one thing about Java, C++, and Python is the index. If you still remember, in MIT App Inventor, the index starts from 1. That's exactly what we talked in 101 class. And then here, the index starts from 0. So the first element has an index of 0. So I'm printing the value of A is exactly the first number. And I'm going to copy again. I like copy paste. So number B is exactly the second. So which the index will be 1 right here. And number C will be exactly the last one in this case will be number 6 minus input 0 minus input 1. That's literally the first number minus so the last number subtract the first number, subtract the second number. So this is exactly, and if you notice, this entire program only need 1, 2, 3, 4 lines of code. The first line I didn't count because that's the input. And then so for this online platform, you can directly click on run. Oh, I'm sorry. I shouldn't put a number there. So as you can see, we immediately see the result here. The 3 number are exactly 2, 2, 7. And at this moment, the power of using Java is we can then try to test with any input number. So let's, if you still remember, I'm going to try the very large example right here. And let's see if we can use Java to help us to see the result, and then we can get the right result. So I'm going to, and again, I have to manually put comma. So within Java, they do not recognize space by default. They recognize comma. So I'm going to put comma to separate these 3 numbers, and then I'm going to run it again. Then we have the result. Let's verify. That's how you try to check whether you get the right solution or not. So I'm going to put it right here and right here. And let's see, do we get the right number? 6312 something something 3265 445 372909989. We are right. So we get the correct solution and then we get the right code. And you can see this is a really simple and straightforward question. And then also by translating it, and if you think about exactly what we did here, set A to the first value. That's exactly what we did here. Oops, I'm sorry. We directly did A to this value, B to this value, C to this value. And this is exactly the 3 blocks we had here. And then print it out. And then sort, we did our own implementation, which I think is a good thing for us because this is a great and amazing practice. So we understand. Oh, you wanted to enter it from the keyboard. If you wanted to get things from keyboard within Java, you do need to make something called a scanner. So imagine we work with a scanning machine and literally scan things in. So I'm going to put scanner in equals new scanner system dot in. So that's exactly how we try to get, if you notice here, system out is exactly print and system.in is exactly what we do in. And I'll say int a equals in dot next int. So let's do. That will become a Java class. Unfortunately, this is not a Java class. This is not a Java class, but if we will proceed towards the end, and then this you probably wanted to do it within the Java class, not really in our USACO class. But as you can see, we gave a particular, this is what we refer as a prompt, system prompt line, and I input a number 5, and that 5 will be giving to the particular integer A. If I wanted to put all the number into an array, I just need to set this into a loop. I need to get, because we're typing all of the number in loop, or you specifically for the actual problem, we are reading in exactly from a file. We are actually reading in from a whole line and then by parsing by space. And again, that's a Java class, not the Go here. I'm very happy that you guys are talking about this. And I will say simply Google, you'll find it. That's just the details for the implementation, not the focus of our class. Now come back to our class. We can do more discussion on Discord. Here, let's see, right here on the slides. Homework time. We have our first assignment, and this question is the question I selected as the second easiest question for the last test season. Again, like I said, you know how to solve the problem, and then how to write the Java code is actually easy. Just towards the very end, that's not the focus now. Towards the very end, we'll spend some time to give a brief introduction about the Java grammar, Java syntax. But as of now, the goal is how do we solve the problems? How do we understand the algorithms? And then we use those algorithms for the question. So how to write an actual Java code, you better go to a Java class. Our class is for USACO. But we will introduce towards the end a little bit about very basic Java syntax and then Java work, and then exactly how to do the Java thing by loading in data from file, process data. But now our focus is on algorithm, logics, and critical thinking. So now assignment time first. Here is a link for the assignment question. And this is, like I said, second easiest question within last year's test season, the whole 4 months test season. And the question here is kind of the year of cow, the year of ox. So everybody know the Chinese zodiac repeats every 12 years. And then so again, Farmer John's cow so one of the cows say cow Bessie is a cow born in the year of ox many years ago, and her friends wants to know how many years apart from Betsy, but they know exactly which animal year they were born according to the Chinese zodiac. So we wanted to find out the exact number. And again, you can read the story. We do not have the time to read all the stories for you, but here is the sample input. The sample input here shows exactly how many cows. The first is the number 4. That means 4 cows are in the file. And this particular 4 cow, that's why we have 4 lines of sentences. And then within this sentence, we have exactly the first one is the name. Second one, so every sentence has exact same format. That let's say cow a name, and then born, and then in, and then the next word will either be previous or next. And then the next word will be the exact animal from the Chinese zodiac. So you can think about these are fixed words. We don't care. And we care about previous or next. And then we care about which animal. And then next word, all the sentences have exact same word, year, from. And then we have another cow's name. That's in cow B's name. So that's the format of every single sentence. And what we wanted to do is by reading these sentences, then we wanted to identify exactly how many years apart these cows from Betsy. So here is the easy thing about this. How do we solve this or trying to get a rough idea about this? And we are looking for solution in MIT AI2. We're looking for a solution for MIT. And then if you want to try, also submit a Java or C++ solution. So again, first thing we want is the MIT AI2 solution. Because in this one, you can think about what we need is go to text split by space, and then we can get every single word within the sentence. After we get every single word within the sentence, all we care about is 4 words. First cow's name, second cow's name, whether it's previous or next, because that means we're adding a number or subtracting a number. And then the which exact animal, because which exact animal means how many numbers or how many we're subtracting or adding. For example, if you think about Madrid born in previous dragon year, which means Madrid is older than Bessie. And then if Bessie is born in the ox year, and then dragon is exactly 8 years more than 9 years, because dragon is in the previous and then Bessie is now with an ox. If we just need to count exactly number within the 12-year cycle. And that's why we already know Madrid is born within 9 years older. So before Bessie. And another example, let's see Paulina born in the next. So the moment we see next, we know he's younger than Bessie. And then Bessie is born in the ox year. And then the dog year from the ox, if you think about right here, is exactly, if you notice, they're exactly 9 years apart too. Because from ox to dog, we're exactly 9 years apart again. So that's all we wanted to find out about this question. And all we need is we need a lot of those blocks for text. And we just need to check, let's see, is this equals previous? Is this equals next? If it's previous or if it's next, we plus or minus a corresponding year from another cow. That's all we need to do for this question. So this is the homework for our for this week. And then if you got stuck, don't worry. We will be here on Monday and Wednesday for office hours. Let's stop here for today. I'll make sure that I get every document and then every application or every link right here being updated on the master document for your reference. And other than that, I think this is it. I will see you guys next Friday. I will update the due date. So I'll see you guys next week. We can stop here for now.
Bye, thank you.
Welcome. Have a good night.
Yeah, wonderful. Thank you so much. See you guys maybe on Monday.
Yes, Monday.
Wonderful. Sunny, can you stop recording?